Hello everyone, and welcome back. In today's video, we are going to learn about push buttons and pull-up resistors using the ESP32. This is a very important concept, because almost every project requires buttons for user input. Before we begin, don't forget to watch all the previous tutorials through the link provided in the description. Now let's take a look at the components we need for this experiment. First, one ESP32 board, our main microcontroller, which will read the button input and control outputs like an LED. Push button. This is a simple switch that allows us to send signals to the ESP32 when pressed. A push button is like a tiny switch. It can open or close a path for electricity. Now let's see how a push button works. First, when the push button is not pressed, the path for electricity is broken, which we call an open circuit. Since the path is open, electricity cannot flow, and the LED stays off. Now, when we press the push button, the path is completed. This is called a closed circuit. Electricity flows from the battery, passes through the button, and reaches the LED. The LED lights up. Resistor. We will use it as a pull-up resistor, which keeps the input stable when the button is not pressed. Now let's understand briefly. A resistor is an electronic component that resists, or limits, the flow of electric current in a circuit. Now let's understand it with example. If we connect the LED directly to a battery, too much electricity will flow. The LED will glow too brightly and can burn out very quickly. That means the LED can get damaged. But if we connect a resistor in front of the LED, the resistor slows down the electricity. Now the LED glows nicely, at the right brightness, and it doesn't get damaged. And some male to female jumper wires. And a small breadboard. Now let's connect the circuit. First we will place the push button on the breadboard. But always make sure that we should never place push button like this. And also not like this. These both are wrong way. We should place it like this. This is the correct way. Now we will place our wires in these both lines. Now we will place our resistor on the breadboard with push button's second pin. And always make sure that your resistor fits in the holes properly. Like this. Now the current will flow from this point to this through resistor. First wire we will connect with push button's first pin like this. And second wire with push button's second pin like this. Now we will connect the black wire with ESP32 ground. Here, like this. And the white wire with ESP32 D4. Like this. And now we will again connect a brown wire on the breadboard with resistor's other end. And now this brown wire will go the ESP32 3 volts 3, that is VCC of the ESP32. Now our connection is completed. So basically we have connected all the components like this. Now, we will just connect micro USB data cable with the ESP32. Like this. Then we will just connect other end of the cable with our PC. Then a red LED will starts to blink on the ESP32 board. Now just open Arduino IDE on the PC and select ESP32 Dev module on the board section. Then just simply copy the code from the website and paste it here like this. Now let's understand the code. So here, we connected the button to pin D4. That's why in the code we wrote #define button _ pin 4. Just like that, the LED is already present inside the ESP32 board and connected to D2. So we wrote #define LEDPIN2 for it. Now let's look at the void setup part. In setup, we tell the board how the pins will be used. The LED is something we control, turn on or off, so we make it an output. The button is something we read from, so it's an input. We also use input _ pull up, which means the board keeps the pin high until we press the button. We also start by keeping the LED low equals off. Loop part. Now, the void loop runs again and again, like an endless cycle. We use digital read button _ pin to check the button state. If the button is pressed, it reads as low because of pull up, so we turn the LED high equals on. If the button is not pressed, the LED stays low, off. At the end, we add a small delay of 50 milliseconds, just to keep things stable before repeating. Now we simply click on the tick button which is on the top left corner, to just verify the code. Now the code is verified. Means it is correct. Now just click on the upload button to upload the code to the ESP32. Now the code has been successfully uploaded to the ESP32. Now, click on the serial monitor button in the top right corner to view the output on your PC. Next, click on the baud rate. Drop down and select 115200 baud to get the correct output in the serial monitor. Here it is. Now, if we press the button, it will show button pressed, LED on. Otherwise, it will show button released, LED off. As you can see in the video, when we press the button, the LED starts to blink. And when we release the button, the LED stops blinking. That's it for today's video. Thanks for watching. Don't forget to like, subscribe and comment.